Today we're going to talk about the subatomic particles that we can find in the atom and how we use those particles to learn about the mass and the charge and how to write the symbol for a particular element. All right, first we're going to talk about the proton. The proton can be found in the nucleus and it has a positive charge. The neutron, also found in the nucleus, which is called a nucleon, has no charge but does contribute mass to the atom. And then the electron are those subatomic particles that move around in a cloud outside the nucleus, and those have a negative charge. Okay, now we're going to review the properties of each of these particles. So as I already said, the charge of the electron is -1, the charge of the proton is +1, and the neutron doesn't have a charge, so it's 0. All right. In terms of mass, the protons and neutrons weigh a lot more than the electrons do. So if we make the relative mass of an electron 1, this means if we had 1 gram of electrons, if we had the same number of protons, they would weigh 1,836 grams, which is a lot bigger, almost 2,000 times the size. And a neutron is very similar. It would weigh 1,841. Right? Now their actual masses I'm going to write here, but we haven't really learned much about scientific notation, and so I don't expect you to be able to do a lot with them, but this is just to show that their masses are very, very, very small, which is what these negative exponents tell us. Now one other thing I want to note is that an isotope is what we get when we have elements that are the same, or atoms that are the same element, but the two atoms have a different number of neutrons. Those are called isotopes. The atomic symbol is how we represent how many of each of these subatomic particles there are. And so X, which is right here, is just the chemical symbol that you find on the periodic table. So this is just the letter or the two letters that we already talked about in this chapter. All right. The number that ends up in the upper left-hand corner of the symbol is the mass number. And so that's going to equal the number of nucleons, which is the protons plus the neutrons that are in the atom, right? And we already talked about those are the two things that give us most of the mass in the atom. All right, and then down here is Z. Z is the symbol for the number of protons, which also happens to be the atomic number for a particular element. Okay, so for any given element, the number of protons is always going to be the same for that element. So an atom of carbon, it doesn't matter how many neutrons it has, it's always going to have 6 protons. That's just part of the definition of what carbon is. All right, and the last thing I want to mention is just the difference between the atomic mass and the mass number. So the atomic mass is the total mass in the atom, and that's actually the sum of the masses of all of the subatomic particles that are present. So it's not exactly the same as the mass number, because the mass number we exclude electrons, and while they are small, they do contribute something to the mass. So it's just important to note that those two numbers are different. And then the last thing I want to say is that the mass that you find on the periodic table is an average atomic mass. And that is different from just an atomic mass because it takes into account all of the different possible isotopes for a particular element and what the average would be if you just took a big sample of that element and divided by the number of particles that you had. So the atomic mass is for one specific atom, whereas the average atomic mass is the average of a large sample of atoms. All right, and so that wraps up our discussion of the subatomic particles, and tomorrow we're going to do a little bit more practice on writing the symbols and determining which parts of the symbol come from which parts of the atom.